Okay guys, good morning. So today we are going to talk about what we call consecutive integer problems. So we need to kind of go back a little bit to what we did, I don't know, maybe the second day of school when we talked about integers, right? So we said, what's an integer? We said integers are like whole numbers and their opposites and 0, right? So 7 is an integer and 734 is an integer and negative 12 is an integer, right? So we're not looking at any decimals. Whole numbers, their opposites, and 0. Now, what does it mean for things to be consecutive? Well, consecutive means in a row, right? If a sports team wins consecutive championships, it means they win 2 years in a row. So when we're talking about consecutive integers, we're talking about integers that differ by 1. They're in a sequence, right? So 5, 6, 7, 8, and 9 are consecutive integers. 57 and 58 are consecutive integers. Negative 9, negative 8, negative 7 are consecutive integers, okay? So if you start with an integer like 12, you can add on by 1 or you can subtract by 1. All right, so that's the important concept here, is that they differ by 1, right? Someone says, I asked this question in class and someone said they're in a row. I said, okay, I say more, right? They're in order. Okay, say more. They have a difference of 1. Oh, okay, great. So now, two consecutive integers have a sum of 35. What are the numbers? Now we can do this kind of using some mental math, right? And dividing by 2 and kind of scrapping the remainder and things like that. But really we want to be able to do problems like this algebraically. So whenever we are dealing with consecutive integer problems, if the first number is, say, x, okay, then the second number, assuming that this second number is greater, we are then going to call x plus 1. And that's going to be our procedure for pretty much all consecutive integer problems. Now, we're going to do lots of different types of problems. They're not all going to be consecutive integer problems. But when we're working with consecutive integers, we're going to say x and x plus 1. Now, an alternative would say, well, let's say we make the bigger one x. Well, the smaller one is going to be 1 smaller. We'd have to call that x minus 1. Okay? Just something to think about because it will come up. So these two consecutive integers, x and x plus 1, have a sum of 35. Okay, so x and x plus 1, right, add up to 35. Okay, well that should be pretty easy, right? Because x plus x is 2x when I combine the like terms, right, which tells me 2x is equal to 34, which tells me that x is 17. But of course, guys, we didn't solve the problem, right? The question says we want numbers. I don't have numbers, I have a number. So I'm going to say, well, x is equal to 17, which means x plus 1 is 17 plus 1, which is 18. So we would say the numbers are 17 and 18. And it turns out it's really easy to check because all we need to do is say, is the sum of these two numbers 35? And we say, well, sure, 17 plus 18 is 35. And are they consecutive integers? Yes, because 17 and 18 differ by 1. All right, the ages of 3 brothers are consecutive integers with the sum of 123. Okay, so I'm going to say the first one is x. The second brother is 1 year older, right? So he's x plus 1. And the third brother is a year older than the second brother, so x plus 2. And if there was another brother, x plus 3, and x plus 4, and x plus 5, and so on. So the sum of these 3 ages is 123, which means x plus 1 plus x plus 2 is 123. Do I really need to write out that whole equation? Probably not. I probably know that x plus x plus x is 3x, and 1 plus 2 is 3. So I'm okay with you cutting to that part of the equation. So I'm left with 3x equals 120, which gives me x is 40. So x is 40, which means x plus 1 is 40 plus 1, which is 41. And x plus 2 is 40 plus 2, which is 42. So the question being, what are their ages? We would say the ages are 40, 41, and 42. And when we check it, 40 plus 41 plus 42 is 123. So now what I'm going to do is I'm going to wipe some of this out. And if you need to go back, of course you can. So I mentioned something else before. I said that you don't always have to make x the first one. So if I have 3 people or 5 people or 7 people or any odd number amount of people, I would actually prefer to make the middle one x. And let's talk about why. Well, if the middle brother is x, the oldest brother is x plus 1, one older, and the youngest brother is x minus 1. Now, how is this going to be easy? Well, when I go to solve the equation, x minus 1 plus x plus 1 is really just 3x. So what's going to happen? I get a different value for x, but the same answer, right? Because if x is 41, x plus 1 is 41 plus 1, and x minus 1 is 41 minus 1. I get the same 3 values. But since I used x for the middle one instead of the youngest, I get a different x value, but I still have the same 3 answers. But the algebra was a lot easier. So I'm not saying that many of you are necessarily going to work like this, but some people, when I show this, they say, wow, I can make the equation so much easier by making the middle one x, or in some cases making the oldest one x, depending on the setup of the problem. So I think we could do this, okay? I'm going to give you guys a little pause here. I want you to try these 2. The second one's hard. Everyone should be able to do the first one. All right, so I'm going to do the first one the conventional way first, and then I'll go back and do it using my little shortcut that I showed you. Not that it's a shortcut, just a different way of thinking about it. I don't like saying shortcut. So I don't really want to write this out, honestly. X plus 1 plus x plus 2 plus x. Why don't I just add the like terms? I've got 5 groups of x, and I've got 1 plus 2 plus 3 plus 4, which is 10. Well, that was pretty easy, right? So I get 5x equals 140. Right, so I get x is 28, but I got a lot of substitution to do. So x is 28, x plus 1 is 29, 30, 31, 32. Now for those of us that thought about doing this in the more kind of elegant way, making x the middle one, this is what you should have had. Now what do we notice here? If I add up all of these expressions, the negative 2 and the positive 2 have a sum of 0. Negative 1 and positive 1 have a sum of 0. So when I add up all these orange expressions, look what I get, right? 5x equals 150. Right, so x is 30. So what happens now? Well, if x is 30, I get 31, I get 32, I get 29, and I get 28. I get the same 5 answers, just with the different x value, since I made x the middle instead of the shortest. But obviously the math I did in orange is a lot easier than the math I did in green. All right, this one's hard, right? And hard in the sense that we haven't done one like this yet. 3 numbers are consecutive integers. All right, guys, so let's do it. We've got x plus 1. Actually, so sorry, guys, again, we're going to let the first one be x. We're going to have the second one be x plus 1. We're going to have the third one be x plus 2. So I've got 5 times x plus 4 times x plus 1, right? So 5 times the first, 5x, plus 4 times the second, 4 times x plus 1 is, now this is where it gets really tricky, 5 less than 8 times the third. So I have to take 8 times the third, and 5 less than that means the minus 5 goes at the end. I don't know how many of us did that. That's why I said this one was very tricky. So I multiply 5 by x. I distribute the 4. I distribute the 8. All right, let's combine my like terms. 5x plus 4x is 9x. Positive 16 plus negative 5 is positive 11. So I've got x plus 4 equals 11. All right, guys, that was a lot of work. That gives me x is 7. Now I still got to go back and substitute. X is 7. X plus 1 is 8. X plus 2 is 9. This is not especially easy to check. So let's see. 5 times the first plus 4 times the second. Right? So that's 35 plus 32, which is 67. We expect to be 5 less than 8 times the third. Okay, so 8 times 9 is 72. 72 minus 5, sure enough, is 67. So it is going to check. But that was a really tricky one, guys. All right, so I don't expect that too many of us. I'm hoping we may have got the left side of the equation set up. The right side was tough because of the 5 less than. Okay, but everyone really should have been able to get the first one right up here. All right, let's talk about some other things. Well, if we know what consecutive integers are, and hopefully we know what even integers are, consecutive even integers, right? So like 6, 8, 10, 12, maybe like -10, -8, -6. And what are consecutive odd integers? Well, we can say like 9, 11, 13, 15, or we can say like -5, -7, -9. What are consecutive multiples of 5? Okay, well, we could start anywhere, right? So I'm going to start with 30, 35, 40. And really, I could have started with 5, 10, -5, -10, 0. 0 is a multiple of any number. Okay, let's talk about how we're going to express those algebraically. So let me go back. This would be good to have in our notes. Consecutive even. If the first one is x, the next one is 2 bigger. And then the next one is 2 bigger than that, and then the next one is 2 bigger than that, and so on. This is the part that trips people up. Consecutive odd numbers are exactly the same. Let's think about that. If x is an odd number, like 5, the next odd number, 7, is 2 greater. And then the next number is 2 greater than that. The biggest mistake that we see on a Regents, on a state test, is people putting this. Well, that makes no sense if you think about it, because if x is an odd number, x plus 1 is an even number, so we're not going to do that. This is our guideline for consecutive odd and consecutive even, because if x is even, x plus 2 is even. If x is odd, x plus 2 is odd. Now, for consecutive multiples of a certain number, multiples of 5, if x is a multiple of 5, like 30, the next one is 5 greater, and then the next one is 5 greater than that, and then the next one is 5 greater than that, and so on. If it was multiples of 7, it would be x, x plus 7, x plus 14, and so on. So, I've got consecutive odd integers. The first thing I do, and there's 2 of them, x and x plus 2. Sum of 104. Easy. X plus 2 equals 104. Well, x plus x is 2x. So 2x equals 102. All right, so x is 51. And x plus 2 is 51 plus 2, which is 53. So what are the numbers? The numbers are 51 and 53, right? So are they consecutive odd numbers? They are. Do they add up to 104? They do. So there's our little check. All right. 3 consecutive multiples of 4. X, the next one's 4 bigger, and the next one's 4 bigger than that. Now, hint, hint, I'm going to put it up here. It would make more sense to make x the middle one, to make x plus 4 the biggest, and to make x minus 4 the smallest, because when I get my like terms, I get 3x. But I'll do it the conventional way. X plus 4 plus x plus 8 equals 180. So 3x plus 12 equals 180. So 3x equals 168. All right, so I get x is 56. When I go back and substitute, if x is 56, 56 plus 4 is 60, and 56 plus 8 is 64. What are the numbers? 56, 60, 64. Are those numbers consecutive multiples of 4? They absolutely are. Do those 3 numbers add up to 180? They absolutely do, so that's going to be our check. 56, 60, and 64. All right, here's the challenge, okay? So let's see if we can do this. 3 consecutive even integers such that the sum of the first and 3 times the second is 26 less than 5 times the third. All right, so we'll call the first x. We'll call the second one x plus 2. And we'll call the third one x plus 4. So let's see how we set this up. Okay. The sum of the first and 3 times the second. So I have to take the first, I have to take 3 times the second, and I have to add them. Okay, that's the first part. Is finally my equal sign. So let's go back and make sure this makes sense. The sum, it's my addition sign, the first number, which is x, and 3 times the second number, 3 groups of x plus 2, 26 less than 5 times the third. Okay, so what's 5 times the third? 5 times the quantity x plus 4. What's 26 less than that? Well, now we have to do minus 26. All right, so I want you to pause it and I want you to solve it. Okay, so let's see how we did. So this is 3x plus 6. This is 5x plus 20 minus 26. Combine my like terms, 4x plus 6. Combine my like terms, 5x minus 6. Now, not that it's going to come up here, guys, but it is okay for consecutive integers to be negative. Okay, we didn't see any yet, but that's not to say that you won't see any with your homework. So if x is equal to 12, I'll bring it down here. That means x plus 2 is 12 plus 2, which is 14. And x plus 4 is 12 plus 4, which is 16. All right, so what are the numbers then, right? Find these numbers. The numbers we found were 12 and 14 and 16. So 3 times, if we want to check it, the sum of the first and 3 times the second, right? That's going to give us 12 plus 3 times 14, which is 42, and 12, which is 54, is 26 less than 5 times the third. So 5 times 16 is 80, and 80 minus 26 is 54, exactly as we expected. So we know that our answers now are correct. So guys, there's your homework. I don't think this is terribly difficult, so you don't have to copy the questions. I want to see your let statements. Now, you don't have to write out let x equal. You can do what I did, okay? I don't write it out. If I'm writing 10 expressions, I'm not going to say let x equals 1, let x equals, let the first one equal x, let the 10th one equal x plus 9 or something like that. So for the first one, you say something like, you'd box it kind of like I had. Let me give you an example, right? Something like this. You can just list it out, or it would even be better if we had something like this, right? My first, my second, my third, so you're letting me know which is which. And then you're going to write your equation, and then you're going to solve your equation. Okay, same thing. The second one's consecutive even. Number 3 is consecutive multiples of 5. So x plus 5, x plus 10, x plus 15. And then number 4 is a small challenge. It certainly isn't anything like this, but it's a little different than the straightforwardness of numbers 1, 2, and 3. So if you're having trouble with number 4, or of course any of them, upload your homework, post a comment on Google Classroom, and I'll take a look at it right away.